All right, so this video is going to finish the rest of this first page. Now, all the highlighted ones are what is left, but I'm not going to go through every single one of these because some of these are kind of duplicates, especially once we get down here. A lot of these are just dealing with finding the equation of a line. So once I do one or two of these with you, just use what I went through in there to see if you can do the rest. And if you have any questions with any of those, then all you need to do is just reach out. All right, so for this first one, the first two, 17 or 18, I'm going to do 18. And it says, find the standard form, find the standard form equation for the circle. Well, the standard form of the equation of a circle is x minus h squared plus y minus k squared is equal to our radius squared. And we never substitute into this x or into this y. They remain x and y because in our standard form equation, if we wanted to know what is our y value when x is 4, we'd have to be able to substitute in for that. So when we're finding our equation, we always are going to substitute in for our h and our k. And we've used our h and our k in other equations, such as our quadratic equation, because h and k for our quadratic is our how we move left or right and up or down, but in this case, it is our center. Right, so that means that this point 5, -3, that is going to substitute our h or k. So that means that where we see h, we can substitute 5. So then this standard form equation will become x minus h, or x minus 5 squared. And then where we see k, we can substitute our -3. So y minus -3 squared is then equal to our radius squared, and it tells us that our radius is 4, so we can then substitute 4 squared. And now we can just write the final answer, so it'll be x minus 5 squared plus here minus a negative turns a plus, so it'll be y plus 3 squared, and 4 squared is equal to 16. So that is our standard form of the equation of a circle. Right, I'm not going to go through 19 and 20 because here it's just saying find the radius. Or I'll go through one of them real quick with you. So for this one, there's nothing being added to. Hold on, let me pause this and erase this real quick. All right, so for this one, number 20, it just says x squared plus y squared is equal to 1. I'm going through this one because it should be kind of similar to 17. So this way you can try 19 on your own. It's a little bit more difficult, but you can use these steps. So for here, we see that there's nothing being added or subtracted to either of these y's. So that means my center has to be 0, 0. Because x minus h, well, in order for the h to completely disappear, it has to be 0. And in order for the k to completely disappear, it has to be 0. And then it's equal to our radius squared. So that means if we want to find out what our radius is, we need to take the square root of this number. And the square root of 1 is equal to 1, so our radius is 1. So for these, since it's plus, just remember that this means that our center has to be a negative value. And then you would just take the square root of the 9, which is 3. All right, so for number 22, I'm just going to show you using a number line real quick, because remember, distance is always positive. So when we're dealing with distance, we always use positive, which means anytime if we want to have an operation that only uses positive, then it's our absolute value, because the absolute value of 4 is equal to 4, but the absolute value of -4 is also equal to 4, because it's telling us how far, what distance we are from 0. And distance is always positive. So the absolute value will always give us something that's positive. So when we're dealing with distance, if I give you -1 and 3, so 0, 1, 2. If we were to count this, this distance is 1, 2, 3, 4 units away. And the way that we can find our absolute value between -1 and 3 at our distance is we can either do -1 minus 3, the absolute value, which is then equal to -4, which is equal to +4. So that's telling us the distance between, or we can do 3 minus -1 and the absolute value. And this will change to plus, which is then the absolute value of +4, which is then the absolute value of 4. So when we're finding the distance between 2 points, it doesn't matter which one we subtract first. as long as if we include the absolute value. If we didn't include the absolute value, then this answer would be -4 and this one's +4, so it is a difference. But once we use the absolute value, that means we're only dealing with the positive number anyway, so it doesn't matter which one you subtract first or which one you subtract second. So when we're dealing with this problem, it says the distance between z and -3 is less than or equal to 1. So you can either do z minus -3 is less than or equal to 1, which would then turn to z plus 3 is less than or equal to 1. Or you can do -3 minus z is less than or equal to 1. So either one of these will give you your proper answer because we're using absolute value, and it doesn't matter which one you subtract first since we're taking the absolute value. All right, so for 23, it's kind of similar to one of the problems that we did already in the last video. But remember, our midpoint is equal to our x1 plus our x2 divided by 2, and our y1 plus our y2 divided by 2. So in this case, I have my midpoint is -1, 1, right? No, endpoint. So my midpoint is 3, 5. And I know that my endpoint is -1, 1, so I can say -1 plus my x2 divided by 2, and 1 plus my y2 divided by 2. So now I know that this 3 is associated with this x, and that this 5 is generated from this y. So I can then create two different equations. I can create one where 3 is equal to -1 plus my x2 divided by 2. So now multiply each side by 2. 6 is equal to -1 plus my x2. Add over the 1. My x2 is then equal to 7. And then the other one I can do is for my y, my 5 is equal to 1 plus y2 divided by 2. So I can multiply each side by 2. So 10 is equal to 1 plus y2. Subtract the 1, my y2 is then equal to 9. So that means my other endpoint would have to be the point 7, 9. All right, so for number 24, finding the slope, I'm just going to give you the formula. You should know this one, but our slope is equal to y2 minus y1 over x2 minus x1. So you're just simply plugging these points into that equation. All right, and then remember there's two different equations that we've learned before. Our slope intercept equation, and that is y is equal to mx plus b, because they give us our slope and they give us our y-intercept. And then the other one is our point slope equation, and that is equal to y minus y sub 1 is equal to m times x minus x sub 1. And the reason why this one is called our point slope is because they give us a point, our y1 and our x1, and then they give us our slope, our m. So these are the two different equations that we learned last year, and I already have multiple videos on this. If you go to my YouTube account, you go to my playlist for geometry, I have multiple videos on this from last year. So if you need more help with this, you can just go ahead and use this. I'm just going to pick a couple I'm just going to go ahead and pick a couple of these questions because all of these from 25 all the way down to 32 are using this. And just remember, when we say that our slopes are parallel, that means that they have the same slope. So if my slope in one of my equations is equal to 2, then the other one also has to be equal to 2. And when I say perpendicular, they're negative reciprocal. So if my slope was equal to 2, then the other slope has to be its negative reciprocal. So that means we have to take the reciprocal of 2, which is 1/2, and make it negative. So those are the two rules that you have to know for when it's parallel and perpendicular. All right, I'm only going to go through a couple of these. And like I said, if you need any help, either check those old videos I did or just send me a message to tell me which one specifically you want me to do. All right. I'm going to only do number 28 and 32. Because when I do 28, I'm going to do it in a way that if you can do 28, you can do 27 because I'm finding the slope. This one's given to us. Same thing with this, it's giving us a slope. This one's written in a different form, and it asks you to put it in general form. So I'm going to write it in general form and then rewrite it into slope intercept like they ask. All right. Or I'm not going to write in general form. I'll write in point slope form and then rewrite it. So I kind of go through all the different things, and then I'm going to do 32. All right. So for this one, for 28, the first thing you have to do, because it asks you to write it in slope intercept form, is first thing you need to do is when you're given 2 points, because we need to solve for our b and our m, and we can't solve for our b first unless they give us our y-intercept and our points. So if they give us x is 0 and then y is a certain value, then we can. But we need to solve for our slope first, and our slope, as I just said to you, is our y2 minus y1 over x2 minus x1. So I'm just going to make this my x1 y2, and or I'm sorry, x1 y1, and this my y2 x2. So our m is equal to 2 minus negative 4 over top of 3 minus negative 1. So then my m is equal to 6 over 4, which is then equal to 3 over 2. So my slope is 3/2. Right, now once I know my slope, I can then plug it into my point, because I said I'm going to plug into my point slope form to get to this. So it'll be y minus y sub 1 is equal to 3 over 2 times x minus x sub 1. All right, then from here, if I want to go ahead and solve and write it in point slope form, then I just need to pick a point, and it doesn't matter which one, this one or this one, I plug it in. I'm just going to pick the 3, 2, since they're positive numbers. So y minus 2 is equal to 3/2 times x minus 3. Right? So if I ask you to just leave this in point slope form, then you can just leave it in this way. But now, since the directions say to rewrite it in slope intercept, we need to go ahead and set it equal to y. So I'm going to have to distribute this in. So y minus 2 is equal to 3/2 x minus 9 over 2. And then I need to add the 2 over. So then this will give me 9/2 plus negative 9/2 plus 2. So I will multiply this by 2 over 2. So negative 9/2 plus 4 over 2, which is then going to be equal to negative 5 over 2. So then my final answer, y is equal to 3/2 x minus 5 over 2. Right, these two equations are equal. They're representing the same line. It's just rewritten in different ways. And since I want it written in slope intercept, I had to set it equal to y, which is why I needed to multiply this in and then add over the 2. All right, so the last question for this video before we move to the next one, because I'm going to keep it, each page will have its own video, is number 32. So it says the line passes through the point 2, negative 3. Oops. 2, negative 3. And it's perpendicular to 2x plus 5y is equal to 3. All right, so in order for us to find out the slope of this line, because we need y is equal to mx plus b, in order for us to be able to do anything with this line, we first need to find out its slope, and we can do that by setting this equal to y. So I can subtract over the 2x, so 5y is then equal to negative 2x plus 3. I can divide everything by 5, so y is then equal to negative 2/5 x plus 3/5. Right, so here is my slope. So then if my line is going to be perpendicular, then that means that this slope would have to be equal to 5 over 2 because it's the reciprocal and it's the negative reciprocal. So now I have y is equal to 5/2 x plus b. So in order for me to solve for b, I need to plug this in because this is an x and this is a y. So negative 3 is equal to 5 over 2 times 2 plus b. Well, when we divide by 2 and multiply by 2, they cancel out. So negative 3 is equal to 5 plus b. We subtract the 5, so b is equal to negative 8. So that means my m is 5/2, my b is negative 8. So my final answer, y is equal to 5 over 2x minus 8. All All right, that is it for this video, and we'll move on to the next video will be for the next page.